I've been working in the Department of Logic and Methodology of Science at the University of Łódź. To begin with, I'd like to say thank you to the organizer for the possibility of being here in the great room of Paraconsistent, for taking part in this conference. I'm especially grateful to Professor Di Ottaviano and Professor Canieri for the guidance. Well, I'm going to talk about Paraconsistent logic in Poland, but we don't have too much time, I guess, to get the whole spectrum of Paraconsistent in Poland. So I just did myself just to recall some very important points in my viewpoint, which appear in Poland. So let's start. My talk will be divided into two parts. In the first part, I focus on the history and development of the discursive logic, discursive or discussive logic, actually. And the second part will be something which we call a look beyond the discursive logic. I'm not sure how much point it will be taken into consideration when I will be presenting this part, but I hope that at least two of them I will be enough time to present. So everything starts from Polish viewpoint, obviously, in 1948, when first paper written by Jaśkowski was published. This paper was written in Polish, as you can see. It was rachunek zdań that's still the sprzeczny, but luckily we have two English translations. First one appeared in 1969, another one in 1999. If you had a choice, I recommend the second one because it's much better in English. Who is Stanisław Jaśkowski? I guess you know more or less. He was a very famous Polish logician, mathematician, also organizer, because after Second World War, starting from 1945, the activity of Jaśkowski was related with University of Tork. And he organized the Faculty of Mathematics, Physics, and Chemistry, and even became a dean of his department, and finally even the president of the whole university. We know more or less about contributions Jaśkowski to Paraconsistent logic, but maybe it's something surprising for you, but that Jaśkowski was also, let's say this way, father of natural deduction. Because in 1926, Łukasiewicz put forward the problem of formalization of deduction methods, usually applied mathematical proofs, and Jaśkowski was one of the students of Łukasiewicz. In fact, Jaśkowski wrote his doctoral dissertation under supervision of Łukasiewicz, and the first result was presented years later in 1927 in the first Polish conference in Lviv. Lviv was a city in Poland, now is Lithuania. And this is the first time when the concept of natural deduction was presented by Jaśkowski. And luckily, I don't know what is the reason for that, Jaśkowski refrained from publishing his result, and until 1934, as far as I remember, but this is the time when Genzel published on the natural deduction and sequent calculus. But in fact, Jaśkowski was, to speak, the first person who proposed this approach to logic. If you are interested in scientific works of Stanisław Jaśkowski, you can find more detailed information in the paper by Jerzy Kotas and Andrzej Jaśkowski. Jerzy Kotas was a pupil of Stanisław Jaśkowski. He specialized, Jerzy Kotas, in algebraic logic. Okay. The question was discursive or discussive. You can choose one of the connections because we can treat them as a synonyms. In the first translation that appeared in 1968, only the adjective discussive appeared. But in the second one, we have both of them, both discursive and discussive. They are treated as synonyms. I guess it's the result of some maybe modern approach to the translation, because we have in Polish adjective discursywny, which means more or less discussive, but discussive is a very archaic word as found in the dictionary. So the better one is discursive, but in Polish discursive means discursywny, which means something related to linguistic, rather is very technical. So if you want to use discursive or discussive, that's your choice. That's not different here in this context. Okay, we as a logician usually need some philosophical background and tell why we propose some of the calculi, for example. The same story with Jaśkowski. In fact, there are at least two reasons why system of Jaśkowski was presented. We have here D2. This is the abbreviation for the system. D because discursive or discussive. 2 because it's two-valued system. There is no hierarchy of the system, just in case the system of Professor Acosta, for example. There's not something like that here. We have only one system, D2. Discussive, two-valued. So there are at least two reasons why Jaśkowski introduced or built his system. First one is vague predicates and imprecise terms, and generic example given by Jaśkowski is more or less as follows. Imagine a group of people discussing on a topic. It may happen that terms they use are vague or imprecise terms, or maybe predicates, and each such a vagueness and imprecision can lead to apparent or seeming contradictions. That means that not real contradiction in the word, for example, like in case in the abbreviation, for example. Now we talk about words, which means it is something like dispute over or maybe about words. This is called also logomahy, as far as I'm remembering, something like that. That means we have different meaning in our heads while discussing meaning of the terms which appear during discussion and participant in the discourse. Another point, it's heavily mentioned by Jaśkowski, but it is a second reason. It was status of working hypothesis in empirical sciences, which means Jaśkowski wrote that it happens sometimes that some scientists cannot explain the results, their experiments by means only one coherent theory. Instead, they are used to applying something which we call working hypothesis. And we can safely assume that there is no contradiction between this working hypothesis. That obviously they can change due times, but we can assume this in advance. This is two main reasons for D2 or higher level D2 was looked at this way by Jaśkowski. All this consideration raise the issue which should be formulated in the terms of formal logic. And Jaśkowski's intention is to, this is a literal translation, find a system of the sentential calculus which, and we have three criteria. First, when applied to inconsistencies, it would not always entail overfilling. Overfilling means make them trivial or complex or something like that. Another point is it would be rich enough to enable practical inference and have an independent justification. If we look at the second and third points, we can come to the conclusion that this formulation of the problem is rather very vague, because we have something like be rich enough. What does it mean to be rich enough? It means that we should have as many classical theses and classical rules as possible. Into justification is hardly said. Jaśkowski, I think, is mine because we have different intuition, I guess. The question is how find such a system? Jaśkowski considered four systems to express his ideas. First was Kolmogorov, the so-called Kolmogorov third system. Maybe this term says nothing, but the system is equivalent to minimal Johansson's logic. We know more or less what it means. From the pair of formulas, any beta doesn't follow, but if we have two formulas, I mean alpha and not alpha, any beta with negation has a main connecting formulas. This is the case in Johansson minimal logic, which means that we are very close to trivialization system according to Jaśkowski, and we should reject this approach. Another point is Słupecki three-valued logic. This is very interesting logic. Jaśkowski considered three-valued matrix with two designated value. And what is very, very important is that implication is understood in classical way, but negation has very strange and usual and original property, and the negation is called rotary negation, just like case in post-logic. That means if we have one, we get two. If we get two, we get zero, and 0 bit 1, just some kind of rotation. What does it mean as a consequence? It means that we have some thesis which is not classical one. That means we get supra or maybe counter classical calculus. For example, we don't have the law of double negation. We have as a thesis the law of triple negation. That means 3 negation in front of alpha give you alpha. Yeah, it's not classical. But unluckily, from the triple of formulas, alpha, not alpha, double negated alpha, we get beta. So again, we are very close to trivializing system. So again, this approach was rejected. Another point, there's only few lines about this third approach. Let me see system of strict implication. Jaśkowski said something like, or wrote something like that, that the set of theses that contains only strict implication is very limited. So this approach is not good in the sense, but is not rich enough to enable practical inference. The final choice Jaśkowski made was the model system S5 of Lógica. According to Jaśkowski, it is the best choice. Why not S4, for example? I try to show that. So, if we back to the beginning, I mean the generic or main example with this group of people discussing on the topic, there is a problem. Jaśkowski suggested that each sentence asserted by participants in the discussion should be interpreted as for a certain admissible meaning of the terms used, or in accordance to opinion of one of the participants in the discussion. And this phrase is treated as or maybe called by Jaśkowski as discursive assertion. The discursive assertion has nothing in common with classical one. We don't have any details for this. It's treated as a connective of possibility. I will simply call it dialogue, okay? From now on. So that means that if we have, for example, the rule of detachment, there is a problem that should be solved, because if we have two premises, if alpha, then beta, and alpha, we should understand the sentences like this. It is possible that alpha, then it's possible. If it is possible that alpha, then beta, and it is possible that alpha. But it's easy to show that beta doesn't follow, because we should be understood as it is possible that beta. It is because this rule is not written as fine. So this is the point when the concept of discursive assertion, discursive implication was born. This is the only reason why Jaśkowski introduced discursive implication. There is no philosophy behind it. It's only technical problem. So here is the definition of discursive implication. What we get, for example, the rule of detachment, discursive detachment as a result. Why? Because this is, after translation, is admissible rule in system S5 fluids. Some question maybe arise. First, why not put diamond in front of alpha or beta? I mean, in front of antecedent and consequent for this implication. It is because you get this formula as a thesis. That means part of the formulas of the form of implication. One is with negation, another one without, and you get beta. So we are very close to trivialization system, and that's why we should reject this definition. What about diamond in front of consequent? We have the same story at the very beginning. This rule doesn't hold in S5. This is why it's covered. Okay, to sum up, we have translation. This is the way we understand discursive logic. Jaśkowski didn't give any set of axiom schema. He didn't give nor any direct semantic for it. Instead, he applied translation method. That means, take into consideration all the formulas expressed in a language of discursive logic, and put in front of this formula diamond and translate connectives. This is the main idea behind this. if you look at this from this perspective, some of the connective looks like a classical one. I mean, for example, negation, conjunction or disjunction, and implication is not obviously, and equivalence as well.
And the last one, there is the possible translation of
this is a good question, I tell you why. Because if maybe we are afraid of lack of symmetry here, but it is on purpose. Because if you put diamond here, I mean, in front of this consequence, you get as a thesis, alpha is discursively equivalent to beta, and negation, this formula, I mean, negation of the alpha is discursively equivalent to exclusive beta, and if you have this part of contradiction sentence, we get only beta. This is only reasonable. This is a technical problem. But again, it's a lack of symmetry here, but it's needed here from this point, because we'll be very close to trivialization of the system. It's made of notations. We know. But some first, what are the formulas or theses of structure defined D2? For example, the law of non-contradiction is something maybe unusual from Paraconsistent viewpoint, especially if we have in mind Professor Da Costa criteria for Paraconsistent. Another point is that we have these formulas. What does it mean? According opinion of one of the participants of the discourse, the person said simultaneously alpha and not alpha. That means it is contradiction to themselves. That's why it's also this thesis. But there is a price. The price is here. That means we need to remember that this formula is not a thesis of D2, and this rule doesn't hold in D2. That means that some people said that D2, I mean, Jaśkowski logic, is an example of non-adjunctive logic. It's not true to be very honest. Why? Because it's true as only if we have in mind this non-discursive conjunction. Otherwise, it's not true. So this kind of generalization needs to be expressed in more detailed way. Yes. So we have another point here. And another paper by Jaśkowski appeared in 1940. But look at the translation. English translation appeared 50 years later. That means that no one but Polish reader was able to read this paper. This is the source of misunderstanding. Some people said that discussive logic is example of non-adjunctive. This is adjunctive logic. This is explain why it is so. Why? Because in this paper, Jaśkowski introduced the notion of discussive.
Who translated? I don't remember. Who translated the paper? The papers.
Second one. First one, it was translated probably by Professor Kotas. Second one by Professor Pelomowski and his co-creators. Okay. Now we have a definition of discussive conjunction. And again, why not put two diamonds here? Because you get this formula as a thesis. Yeah? What about left or right? It depends on the direction. So this is still open for discussion. Jaśkowski didn't mention one is the reason. What's more, there are some papers, for example, written by Professor Da Costa and the Unicamp, where this kind of definition of discursive conjunction is considered. Obviously, we can define one using another and so on, but it's not original Jaśkowski definition. Should be aware of this fact. Okay. Now, again, to sum up, we have translation function defined here, as you see. So the discursive logic, the general idea is that we should put diamond from every formula and then translate discursive connectives into classical and modal operator. Yeah. And there is a some trick here, because if you look at this connective, for example, a discursive conjunction, implication, or equivalence, they look strange in the sense that they look as a classical connective, not non-classical connective. But in fact, loosely speaking, they behave classically, which means that positive part of D2 coincide with positive part of classical logic. We have the same. But something that happens in Paraconsistent something like a Paraconsistent-like way, if we add negation. Well, this is one of the tricks was applied here, which means that we have non-standard connectives, we have definition of them, but this connective behaves, let's call this way, as a classical one, and we have something like standard definition of the translation of negation, but negation is not classical. Here, this is a trick by Jaśkowski. And this is the key point, I mean the main theorem, only the by Jaśkowski. First and third point tell us that the positive part of discursive logic is equivalent to positive part of classical proposition calculus. Point number 2 says that if you have no more connectives than disjunction and negation, you have classical logic. That in a sense that the tool contains all the theses, classical theses that contain no more connectives than disjunction and negation. And this is point here. What's more, we have bottom. From bottom, everything follows. In fact, it's negation of the law exclusivity. This is very important because there is a problem of algebraization. And one of the person who has great contribution to the problem was Jerzy Kotas. And Jerzy Kotas showed that we are unable to define complex relation by means of discussive indication. But he found a solution to the problem that I showed you. But one of the very important point is that he also showed that if we limit ourselves to the positive part of discursive logic, we get that is simply in a classical sense. This is because of these meta theorems. Okay, which of the formulas are theses of the two? For example, again, the law of tradition, we are in contribution to Professor Jacob da Costa, for example, formulation of paraconsistency. But we have also some kind of strange definition, for example, as a result. Why? Because, metaphorically speaking, diamond is hidden here. That means if you have diamond before alpha, which precedes alpha, we should have also here. That means the order is a little bit changed. What's more, we can't change the order, it's not a thesis. And obviously, the famous da Costa thesis, it's not thesis of the two. Obviously, if we delete the as a subscript. Maybe before further, a short historical note. The year 1967 was somewhat of a turning point in the development of discursive logic. In that year, Jerzy Legubikaitis was a student of and assistant Professor Jaśkowski. Legubikaitis specialized in geometry. Died about 8 years ago, as far as I remember. Anyway, Legubikaitis presented or gave a lecture on the discursive logic at the Polish Mathematical Society. What's more, in 1967, Legubikaitis met Professor da Costa, and a year later, joint paper appeared on the discursive logic, where first algebraic approach to discursive logic. So this was start of collaboration between Polish and Brazilian knowledge. We can treat obviously the two as a modal logic. So the problem is as follows, or maybe a question arises like this. Is it possible to define the two using other modal logic than S5? So a little bit changing definition is that S5 we have something like MM as a modal logic. We don't know which one now, but we can go into the text. The question was answered by many authors, for example, by Tomasz Kulmanowski, Professor Kulmanowski, Błaszczuk, Dziobiach, and in more recent publication by our colleague from Toruń, by Maciejewski and Przygiewicz. Yes, which of them is the best background for our consideration basis, modal basis. First, we should show something like that D2 is finitely axiomatic system. The idea behind this is as follows. What is the reason for using discursive implication? We can just use modal operator, I mean possibility plus classical. That means I can use the language of S5 instead of language of D2. And then I can give some kind of maximization. This would main idea behind this work, or this was given by Kotas and Costa. But we have also this kind of definition. I should be called simply diamond S5, just to be very brief. That means we have in mind all the theses of S5 that have as a main connective possibility. In some papers, this system is also denoted as a J. For example, Professor Ottaviano wrote a paper about J3. She gave three-valued semantics as well. Now, this is the first axiomatization. Maybe it looks strange at the first sight, but let's forget about these boxes in the front of these formulas and in front of the premises and consequent conclusion in the rules. So what can we see? We have a language which consists with the connectives as a primitives, with negation, implication, and box. That means necessity. And 1, 2, and 3. This axiom. This is axiom for classical logic. Obviously, we have group of detachment, which is hidden here, just beneath boxes. Now we have axioms for modal logic. We have K, we have T, E, and we have 5. That means the relation must be Euclidean. And what's more, we have gather rule here, just beneath one. That's obviously thesis, and we have two rules for, which is called the modalization, something like that. This is axiomatization of the system ML of 1, and if we put in front of each of the axioms diamond, and we put in front of the premises and conclusion also diamond, all of this axiom will be thesis of S5, and every rule which was mentioned here is admissible in S5. This is the main point. So we have here. But a slightly different axiomatization was presented by Professor Da Costa. As you can see, the set of rules was narrowed down, but in fact it is not, because we have very special axiom number 4 and number 1. As we know, there's infinite thesis of CPCs, so that's why this looks nice, but in fact it's by far more thesis, which will be treated as an axiom here. And again, we have the system diamond S5. Before going further, we should explain one more thing. We should establish the equivalence of D2 and diamond S5. From D2 to S5 is quite simple. We have a definition given by Jaśkowski. But we have here some kind of modification of this definition. But remember, we have negation, disjunction, and box taken as a primitive symbols. That's why we don't have diamond here. But by the Morgan law and definition, or maybe a law of duality, modalities we get from this. This is how we translate discussive, not only discussive, connected into smaller counterpart, but we have also second translation. That is how we translate books into discussive connectives. And we have top here, and we have discussive conjunction. That means this is a hidden diamond in this place. If we use the Morgan law, we get box. What does it mean? The interpretations establish the equivalence. This is what's called by application. Okay, back to the main question. It is possible to define D2 using other modal logic. Tomasz Furmanowski answered it affirmatively. It showed that the axiom schema can be provable in this axiom. He proposed. He used, instead of this axiom, just the case here, Jerzy Kotas used this axiom, which is well known axiom called form, and we have transitive. And we have a theorem that this is the same system. So what is the smallest normal model system? This question. It was this puzzle, or maybe this was solved by, this problem was solved by Professor Janusz. He proposed this kind of axiomatization. I call it diamond cast A star, but in fact it is much stronger. It is a D system D with which is some strengthening of D, and we should have something like diamond D, but we have D2 and we have D, so maybe some confusion. That's why it is K instead of D. So we should add this axiom plus to this rule, and we see this kind of axiomatization. And again, this axiomatization is the same as well. We reduce axioms step by step. This is the smallest normal model system, but our colleagues showed that we can use even weaker model system, weaker than diamond K star, by defining discursive logic. Which one? One of them, take it from now. Regular model logic contains all classical tenses, detachment, K, duality of model operation, and, for example, is constant monotonism. And one of the very important facts is that for any regular logic, we have equivalent conditions that should be falsity, which means that this formula should be tenses, this there, and at least one formula of the form possibility alpha is also thesis of regular model logic. As a result, some of the criteria were given by Jaśkowski and Ciuciura. That means that the smallest regular model logic defining the two must contain these three axiom plus should close under this rule. So we found even weaker system is known from the normal model logic. There are any weaker? I guess there are, but people work on the problem all the time. So for now, it is the weakest known system. Okay, another question on the problem with discursive logic is the system algebraism? There is a series of papers written by Jerzy Kotas. Jerzy Kotas was a student of Stanisław Jaśkowski. He specialized in algebraic approach to logic in general in algebra. So the first step is like this, winning translation, and the idea is that we know that S5 is a basis for D2, and why not use simple algebraic interpretation of S5? So we have Handel algebra, which is understood here as a Boolean algebra plus extra operator, interior operator, which obviously is nothing but box. That means necessary. We also additionally define the logical operation that we see. Now, the concept of discursive algebra appear. That means, which we already know, because as we remember, one of the meta-theories that was given by Jaśkowski as follows: discursive logic contains all the classical theses in which apart from variables we have as a primitive symbols, negation and disjunction. So we have an algebra, and we have two more operations defined here, something like discursive mid or discursive order. Well, if we have this, we can define the class of all discursive matrices of the form given. Why we have A minus 0? Because we have diamonds in front of all one. This is the main reason. And it was proved by Da Costa and Unicamp that this theorem is true. And again, it's not something like that. H alpha is equal to 1. We have H alpha is not equal to 0. Again, because of the possibility function. That means operation. Another question that can be asked in this context is that why don't use, why we should use translation here? Maybe we can be free up from this translation. Maybe we'll be able to define in more or less standard way. First, equivalence relation, then we get congruence relation, and we can be able to finally get no, this is one of the theorems given by Cotes, which shows what is the problem with discursive implication. If we have this definition of implication, we can see that this is an equivalence relation, because we have the law of identity, we have transitivity of this implication, and we have symmetry by definition, and we have also the rule of detachment. But this is not congruence. Why? Because this condition doesn't hold. So what is solution for the Cotes absolute form? Before, let's have a look at the definition. It was in 1971, that means about half century ago, when Jerzy Cotes defined logical system with implication. What does it mean, a system has implication? It means that among logical connective of the system, there exists or is definable at least one such a connective that fulfill the following properties. And we have here the law of identity, we have the rule of detachment, and we have transitivity, and something which we call a condition for congruence, like that. We already know that this first, second, and third condition is fulfilled by implication, discursive implication, but the last one, no. So this is the main problem here. And what does it mean? Discursive implication, not implication in the sense of Cotes. What is the solution for that? I mean this second. It is possible to define a new connective that will have properties of implication in the sense of Cotes, by means of which we'll be able to define equivalence relation and get congruence. It's not here. I just. Okay, it's here. First, we should consider a language, or maybe we should limit the number of connectives, or confine ourselves, limited ourselves to have only 3 connectives as a predicates, that means negation, conjunction, and discursive conjunction. We can define implication, discursive implication this way. And this is the key point here. We are able to define a new connective of implication. What is the meaning of this implication? If you look at this definition, it's clear. By definition, we get something like that, this negation of discursive conjunction. So if we use translation, and we have this definition, it's negation of top, or in fact, we finally get something like this. That means we get strict implication. Strict implication is definable connective in D2 of Jaśkowski. And this is the key point, because first, the rule of strict detachment is admissible in D2. The formula of this form, I mean, the law of identity for this implication is a thesis of D2. The rule of strict implication is also admissible. What's more, you have associative law, independent law, the law of absorption, but in the case of completed laws, we have this law with disjunction. If we have, for example, discursive conjunction, it's not thesis. So it will be a problem in kind of lattice, but not commutative lattice. Yeah, it will be skew lattice. Now we have a remark. This is not thesis, obviously it's not with this context law doesn't hold. It's not a thesis of D2, and the same story with this law. But if we have the direction, it is a scheme system. If we have this kind of implication. So we finally get what we wanted to get. That means this relation is equivalent relation, and we have congruence. This is solution. Very simply trick what was applied here.
Does it hold the theorem of the deduction method theorem for this implication? Sorry? The deduction method theorem.
There is no deduction. There is no any either deductive or metatory for this given by contrast. This is for him, it's a kind of technical problem. That means I want to gather, or maybe I want to show how to algebraize discursive logic, and I need some kind of trick. That means I need a new connective that can be defined, and with the help of this connective, I get this equivalence relation that comes then. There is no metatory.
But it has a lot
but we
of
can do
good
this,
properties. So.
Yeah, we can do this, but it was not mentioned by contrast. Now we have quotient algebra. That means we are able to translate discursive connectives into the algebraic counterparts. And we have definition of skew lattice. That means that this structure and operations are joint and mid, which are associated, independent, and satisfy the absorption identity. It was skew lattice in the set of Jordan. We have nowadays no modern approach to the problem, obviously, and we have some extra additional terms we can use, but Kotas use only this notion of lattice, skew lattice. And we have algebra, the form, we have Buran algebra and skew lattice in the Jordan set plus some of the condition, including order. And we have very strange, maybe at the first look, definition of the tenses, because we have unit and we have something like discursive. Joint alpha is equal to 1. Not simply A is equal to 1. It is because, again, the diamond is hidden here. It's the main idea, because we should present all the tenses by the reservation in accordance with which this reservation is identified or treated as a connective of possibility.
What is the name of these algebras?
Which one?
What is the name of these algebras? Kotas algebras?
Kotas code is a discursive algebra or something. You can find more detailed information in this paper. There's at the very beginning I show what is the reference to this, but it is called like discursive algebra or something like that. It's discursive is the best. And now we have a theory that means we have to define filter property of the algebra, and we are able to define discursive matrix or D2 matrix. What is kind of matrix? It's here. That means that we have Buran algebra and some additional properties. This only repetition. But some people doesn't like, for example, algebraic approach. What about given direct semantics, which was expressed in the Greek semantics? About possible word semantics. Before my doctoral dissertation, first one. This is a kind of semantics. We should also remember that Jaśkowski treated this D2 as a set of theses, not as a consequence operation. So that's why we have this definition here of validity in this model. So we have a D2 frame, which is a part of the R, and W is non-empty set of point, possible word, whatever you want. And we have R as a equivalence relation defined W, and D2 model is a triple relation of V, which is mapping, which is defined here, and we have condition for connectors. It maybe looks strange at the very first sight, but you should remember that we have diamonds here. It's a zero. So that's why. But we have one more restriction. It's hidden here. It's not simply alpha is valid in D2 if only if for any D2 model for any point. No, it's not. For any point exists point H. Why? Because we should preserve each formula by reservation. That means by the diamond. Now we can simplify this semantics because, as we know, we have very nice property of relation, accessible relation in S5 because it's not only equivalence relation, but it's also universal relation. That means any point is accessible from any others, which means that we simply get rid of error from our condition was given. So again, we have like here, and we have box because it's or. And again, something which looks strange because again, we have for any to model there exists age, not for any, there exists age. Again, because we should proceed each of the formula by the reservation in accordance and so on. We can also define semantic consequence using this notion, but it was not Jaśkowski idea in general because Jaśkowski rather focused on the treated the two as a set of theses. And we have this remark, alpha is valid in the two if only alpha belongs to the two and only if the translation belongs to this. Okay, what about making some of the calculation more automatic? What about Tableau for example? I propose three versions of Tableau. First Tableau we work with so-called sign level formulas. This is formula of this form. Sigma is a level, T is a prefix, P is a formula. This is called prefix formula. It should be written as P is true at the word sigma. I change notation here, that means I don't have alpha, beta for formulas just to avoid some kind of confusion because we have a small big letter which was assumed to be a level. And in personal proposition, I took into account non-empty sequence of natural numbers separated by dots. In this way, we understand the level. Level is understood. And we have a rule here. We have a standard definition, extension, what the Tableau is for that formula. This is non-discussive rule. As you can see, we have branching rule here and linear rule. If nothing interesting, we have a discussive system. Also, you can also use other slightly different or general terminology. You can say something about alpha rule and beta rule. For discussive rule, we have something like this. This is an important point because n is a new level, tau is a level that was used. If we translate in our head into discussive, from discussive language into language of S5, notice this is simply here diamond. That's why we have new level and level. And again, the same story with implication, we have closure rule, but very important point, we need hereditary rule, special rule. That means rho is a root level, and we can transfer this formula to any word which is accessible. Without this trick, we don't show that some of the formula have a closed Tableau, for example. How it's worked in practice? So that means we start, for example, this formula is we have rules and look at the line F. We need this because we will finish here. And we can transform this formula to the new level 1, is because this rule that we close and we get closed out of this formula. Okay. Another point is that what is the reason for treating level as a sequence of natural numbers separated by dot? Let's treat it as a natural number. It makes life simpler. And again, we have the same rules, classical rules, and we have some modification here. We have tau as a new level and sigma prime as another rules. And again, we have closure and this is modification. We don't have something like 1 and so on. We have 1 and another level is 2. Let's make some of the rules. There is a third one. Tableau unsigned. We don't have any prefixes here. This is the set of rules. We have indication of this different words as well here. Just do it because we are running out of time. So the closed tab, example here, we can show that this closed tab law of the multiplication. Maybe two important points, just to finish. First, if we look at this definition, this definition looks like this well-known from the Discursive Logic. We can define this way very strong negation. In fact, this classical negation. That means that we treat negation as not possible connective. So we have a translation here. Now, let's forget about translation and take this connective as a primitive symbol. So we have a first translation. Now we have semantics, and we have the key point. This is the same system as system of classical proposition logic, which means that we have classical negation, and this definition of the model is nothing but yet another semantics for classical proposition calculus. This very easy way by means of Jaśkowski. I know the Jaśkowski discussive system. And the very last things, I think you find this very interesting. This is Hirsch system. In my opinion, although Hirsch constructed his system without any idea of paraconsistency, but we can extend this system in a very nice way and get paraconsistency in a very strong way. Short what I mean. The system is defined by this axiom. There is no rule of detachment in this system. This rule is not derivable in the system. We have only these two axioms and these three rules. When we get all the theses of classical proposition calculus are probable in H, included pseudo-Dusko thesis. But not every rule of classical proposition calculus is derivable in H. For example, we don't get the rule of detachment and the principle of exclusion. We have a proof, for example, that this formula is a thesis of the system, and we have a matrix that shows that, that this two early mentioned rules are not derivable in the system. But what about extension? Look at this x. You can extend this calculus by adding this x. Alpha is any formula. It can be variable, for example. So we have, as a thesis, negation of B. Why? Because it's massive. What we did next? We have something like that. All the classical propositional calculus are probably extensions of H. There exist parts of formulas, such as alpha and not alpha, which are both tenses. They are expressed in the language of classical propositional calculus. There is no extra symbol. There is no extra variables. There is no extra connectives. Because as far as I know, there are only three, maybe more systems where something like that is possible to express. I mean, this is the system V3 proposed by Aruda as axiomatization of imaginary logic. But we have there some extra symbol. It's non-classical negation, non-classical conjunction. And we also have the logic of antinomy that was proposed by Asen and Tamburino. But we have something like antinomic variables, and special variables added to the language of the system. That means we have as axiom A and not A. But it's not variable in the sense of classical proposition models. The same story is in dialectical logic. This was proposed by Meyer and Robley. Look at this. Not every formula is the thesis of this decision. For example, not every rule of classical propositional calculus is derivable in H. For example, we don't have the rule of detachment, the rule of exclusion, and the rule of negation. So, to sum up, H is a contradictory dominant, and is not subsystem of classical proposition calculus. But what about example? Look at this. We have B plus C is a classical thesis. So we know that our extension have all the classical theses. And we have axioms. It is not the case, but it could be. So we have formula and negation of this formula expressed in the language of classical proposition method without any additional symbols. One is in contradiction to another in the sense of negation. But this is not trivial system. We have proved here why, for example, the two I mentioned before are not relevant here. And the last one here. So we have different axes. We have three negation, for example, three negation and variables. What we get? All the theses of classical propositional calculus are probably in H. There exist formulas such as, for example, this one, in which both are theses. Not every formula is specific on H. I mean, P, not P, not P, for example. Not every rule of classical propositional calculus is very well in the system. It's extension of the H, for example, it's not radical, but not trivial, it's not a subsystem, and so on and so forth. So this is a different way to think paraconsistency. So this is not the problem of negation, maybe it's the problem accepting the rule of detention. Yeah, if we eliminate these rules of our system, we may get something interesting, but the surprise we have. There is a lot of complications, very non-standard approach. So many standard rules we can do with the rules of detachment is not accessible this way here. So I finish here because something more about gently paraconstant, but we are running out of time. I'm sorry that I a little bit took a little longer than it was expected, but we also start a little bit longer. So thank you very much for listening.
There's the time for questions.
Yes. What about a calculus allegensen for this logic?
I don't know about this. I guess if we have a discursive connect, it's easy to get it. But I don't know how to, let's say in a metaphorical way, how to translate this rule that we should precede each sentence by the reservation. I mean, what I do this now. But we have natural reduction. Natural reduction for this system, but in fact it's some kind of trick because we define in this natural reduction approach classical negation. But if I read your intention properly, you have something like we have a weak negation, we have classical discursive connexive, and something like that. There is no such approach as calculus. There is no secret calculus. I mean, that's just for your example.
Mas pode perguntar. Anyone?
In your Tableau system, you couldn't use a standard Tableau system. You use some kind of label.
Yeah, this is standard approach.
Is
Some of the rules are not
you need
standard.
to keep track of levels. You need to keep track of levels.
Yeah,
in the deduction.
and especially meta theorems, because we have something like going at infinitum. We generate infinite many levels. There will be some cases like it, but we can solve this problem just some case in model logic.
That's right. Yeah. Well, I see that strategy in Jensen systems for model logics.
Yeah, it's very short. Yeah.
Janusz Ciuciura, Professor Ciuciura, I would like to thank you for having accepted our invitation to participate in this logic school here, celebrating Newton, the 90th years of Newton da Costa, because it would be not acceptable if we had not a Polish logician here representing the so important, let's say, Jaśkowski's Paraconsistent school. And so it's an honor for us having you here. I would like to thank for the so beautiful talk. I have some observations and one question. The first observation, we must recall the importance of Jaśkowski in the creation of natural deduction systems. Because usually we read in the literature that Gensen was the creator, but Jaśkowski, in effect, creates systems before Gensen. Also, I saw now when you were presenting that Jaśkowski justified why he had preferred to use the system S5 in order to introduce his formal axiomatization for his discursive system. You said that he didn't want to use Kolmogorov's system. We have spoken about Kolmogorov's system here in our course, Principle Translations between Logic. It's the paper cited, mentioned by Hercules, a paper published in 1925 in the western side of Europe. People didn't know that paper, and Jaśkowski, it seems that he knew the paper. He didn't opt for using Jaśkowski's Kolmogorov system. My other observation is your talk showed us how close are the Brazilian Paraconsistent school, Da Costa's school, and the Polish Jaśkowski Paraconsistent school. They are very interrelated. But I used to discuss with Evandro the motivation for the creation of the systems D2 and the systems created by Da Costa were more or less similar. They wanted to deal with systems that could be contradictory but without a trivialization. But the solutions were very distinct. Jaśkowski and the Polish school opted by creating and developing systems based and related to known systems, to model systems, to S5 and other model systems. But Da Costa created a hierarchy of Paraconsistent systems completely new, not based on new or known other Paraconsistent systems. The intuition was the same, but the creations were distinct. Do you agree?
Yeah, to some extent. But,
Yeah.
I would like to add one more information because one of the speakers, I don't know, a few days ago said that Kolmogorov was the first Greek translation procedure to show some kind of equality between the system. I'm not sure to the very end this is true because also Łukasiewicz did the same thing. I don't know, I'm not sure it's Łukasiewicz was the first, more or less, because I read about it a few years ago, I don't remember clearly. Maybe at the same time, maybe a little later, but not only Kolmogorov used this procedure, that's why, for example, Jaśkowski used it, because Jaśkowski was a student of Łukasiewicz, and during his seminar, I think so, Łukasiewicz used, or maybe demonstrated this method in translation. He applied to some of the system, but I don't remember clearly.
But Kolmogorov's paper was written
In
in 1925.
1925,
Before
before.
other papers.
This was close time connection.
I have another question specifically. Janusz, I remember, and it's written in one of his papers, that the translation from Polish into English, the translation using overcompleteness for Jaśkowski Polish term, that a system could be contradictory without overcompleteness. And Janusz said that this was not a good translation from the Polish language into English. You used overfillness.
There is a word such as this, but was not accepted. Inconsistent, I don't remember. It's something with inconsistent, something. Plus some kind of word in front of this, but I don't That's true. There was used a new word. Sorry? Yeah, para-inconsistent.
No, this is other thing. During the Ghent meeting, Janusz proposed that instead of accepting the name Paraconsistent logic, he proposed para-inconsistent logic. But I asked him, but this was not accepted in Ghent. He also proposed this in Torun during the first Jaśkowski Memorial Symposium, but this was not accepted in the literature. But my question is another. Janusz claimed that the translation from Jaśkowski paper of the Polish term used, which was translated into the English literature as over-completeness, was not a good translation. The translation, and then
We don't have in Polish one word for paraconsistent logic. We can
No, but
just
there was
simply
not this word.
I know, but we have in Polish logiki tolerujące sprzeczność. That means we have 3 words to repeat this. So this may be a similar story with this. Yes. This is overcomplete, overfilling, make trivial, this kind of thing. You have to, obviously, Jaśkowski used the term overfilling.
overfilling.
Overfilling, yes. But this was not good translation. But it was done.
Okay, thank you.
Thank you very much.
So now we have the last session of the talks, right? The first speaker, young guy.